Thanks for tuning in to This American Life, brought to you by Brenner-Fiedler. I'm your host, Jeremy Schubert. Each week, we bring you experts on technologies used in the automation industry. This week, we have Caleb Zwar, specialist for Barcode and ID from Brenner-Fiedler, here to discuss ID technology. So, Caleb, when we say ID, what does that really mean, or what does that encompass?
Sure, yeah. ID encompasses a lot of stuff. It stands for identification. So that can be a various form of how do you identify your part. Meaning a lot of times in manufacturing, customers want to have traceability.
Okay.
And that word is thrown around almost the same as ID. So meaning company A wants to make this part, and this part has 5 parts to it. But they want to make sure if there's a defect down the road, they can trace it back and say, okay, at what point was this made? Which day was it made? Who was it made by? At what time? So that way they have traceability they can put it. Now it's either a mark on the part, or it can be as much as a part embedded into it, like an RFID would be a case.
Okay. So. Or even like I'm thinking of samples in a medical analyzer, so you know who that sample came from.
Yep. Okay. And a lot of times it can be used for the consumer part. So like in a grocery store, you see parts have barcodes. That way, not only are that data can be traced back to when it was made and where it was made, but it also can be used at point of sale. So, like in the medical example, they use that sample can be traced all the way back to origination, or it can be used on a daily basis. Hey, this is what we used. They do a lab testing. They go back to the same thing. So, the IDs can actually be used in multiple locations.
They can see like a batch of reagent they used or to test something. Okay, cool. So, what are ways that you can ID a part?
It's funny. It seems like more and more every day. So, before it started with a barcode. Meaning that basically, it started with serialization, where they would actually stamp a number on a part.
Okay.
So that goes all the way back to, when manufacturing started. Hey, they want to identify this steel part, they would stamp a number into it.
Okay.
So then basically, as progressed, they got plastics and that. They said, hey, we don't want to keep stamping a big number in this, so they created barcode. So the barcode basically is a series of, everybody's seen them, it's on every grocery store, but basically a series of lines, and that line is basically just a number. Same thing, same number, it's just this is in a barcode format. And that kind of came around to people didn't want, before they used to stamp date codes and that into it, and they didn't want people to identify them and say, oh, somebody can tell when this was made or where it was made and that sort of thing. So they made a barcode, which was kind of their way of hiding the number, so to speak.
Well, that's always good.
Yeah, exactly. And then they can't read it, though. That's the problem.
So, it kind of came back around, though, because a lot of products will have best by dates on there, and date of manufacturer. So that's changed. Yep. I got to stump the expert here. When were barcodes kind of first introduced? If I was in a grocery store, if I was in there in 1964, do they have barcodes?
Not 19. That's around the time. Basically, I want to say the first commercial use of these started around in the 80s.
Okay.
I would probably have to check on that.
Okay.
Good question.
I had to know.
Yep.
So I know there's different types of barcodes, and then there's the QR that everybody's using. Every real estate agent has on their business business card. What are you don't have to run through all of them. I'm certain there's probably a lot, but what are some different types, and how do you know when to use certain ones?
Yep. There's way more than I really want to talk about, but basically there's variations of, they kind of separate them into 1D, they call it, and 2D.
Okay.
So 1D means one dimension, and all that means is basically those are the standard.
That's a classic UPC.
Exactly.
Okay.
Yeah, and those are the one that started with, I believe, was code 39. I think it was the first version of that.
Okay.
And that's a very simple. I think it's alpha only. You can't put numbers in it. I think it's just letters only. So very limiting on that fact. Then they came out with code 128. Which adds in numbers, so now you can use numbers and letters.
Okay.
And then there's UPC can, I think, even use special characters and that. So those are just your standard line types. The limitation with those, they're very fast to read. That's why the post office used to use them for years, and that now they actually went to UPC codes and that.
You've got basically on-off signals there, right? So if this bar is on and the next one is off, you're basically getting a digital representation of a number through bars. Okay.
It's very similar to Morse code.
Okay.
Yeah, you have a thick bar, thin bar, thick bar. That equals an A, a B, a C, and then they do it in correlation. And then at the ends of the code, they call them like checksum, which means the dead space is just beginning, ending. Okay. So that way, like a laser reader, which is how they started, a laser reader can go across there, and when they started, it was just an analog value.
Okay.
A high, low value, light, dark, light, dark, light, dark.
How much laser is coming back?
Yep.
Okay.
And then they translate that into thresholds, and that's how you get your digital signal: on, off, on, off, on, off. Cool. So that equals a number, just like Morse code.
Cool.
Then, due to the limitation of those, because those are limited to character numbers, I think, like 100 and something characters is like the max you can get on a 1D.
Low 100 characters. Okay.
Right.
Cool.
Now, then they basically created a stacked code, which they call it. That's on like an airline boarding pass. It used to be. That. Yeah. Right on the bottom there. It's essentially a 1D code that has been, it looks like a 1D code that's been smeared, but basically it's been chopped and then rearranged.
Yes, yeah.
So those were stacked codes. Those came out next, and they used those. I think it was actually the airlines. They kind of started it because, hey, I need more than that, or I want spaces, and I want to put the person's name, address,
128, number. But I need 250, so not a lot more, but more.
Right.
Okay.
So stacked codes then, I think then, it was either UPS or the post office. They got a hold of it, and they made postal code, which is still used today. It looks like a large one of those QR codes you're mentioning, except that the QR logo, instead of being in the corner, is in the center.
Okay, yeah.
So that was actually proprietary to just, and I want to say it was the post office. And that kind of rolled into people like, hey, this, you can use way more data. It's the same sort of stacked code, except that instead you just have square.
So you have more stacked, basically.
Exactly, yeah. So now
rows and columns of data. Okay.
The issue with those codes is that they start to get too complex for the readers. So now they've introduced redundancy. So like a code, like a data matrix code, actually is built in 4 quadrants. You don't really see it, but basically that way you can have, and again, I think the post office was involved in this, you can have a chunk missing out of your code. Okay. But there's actually 4 codes built in there. So really you only need one of them to be readable.
Okay, and you can probably compare and do kind of error checking.
You can, yeah. Cool. Then you get into code grading and that.
Okay, so. Cool. So that would be your 1D and 2D types of codes.
Yeah, the 2D is the two-dimensional. So think of it, one way is the 1D, linear. Then 2D when they start to go up. Okay. So then you have, left and up and down.
Yeah, I know also people have done OCR, where you're trying to actually read characters. Is that... That's difficult, but is that used often?
More and more.
Really?
It's a technology that came out in early 2000s where they started actually looking, taking a camera, reading, snapping a picture, and then the picture would then identify, okay, this is an A, this is a B. It started out really weak. It had to be a certain typeface, and it had to be, at a certain clarity. Getting better and better and better. A lot of it now can even read handwriting, where you actually, it's due to the software capabilities now. So now you can snap a picture and almost read, sometimes it actually can read handwriting and then say that's an A, B, C. Then it correlates that into, you can actually do whatever you want to correlate that back to a code or back to, just give me the string of data.
Gotcha. Okay. And then I'm sure the advantage there, it seems obvious, like a person can read it and a machine can read it. So either way, you've got somebody that can...
Yep. Cool. Yeah, OCR stands for optical character recognition. So it can be any characters for that matter.
Cool. So, of all the different readers, I know that there's, if we go to just specifically talking about 1D and 2D barcodes, I know there's handheld readers. I see people carrying around some crazy ones with buttons. I see barcodes that are mounted on a machine. Kind of what do you determine? Because I've even seen a guy like putting something underneath a fixed barcode reader. Okay. So, how do you kind of determine what's the right kind of reader for your application?
Yeah. I think in readers themselves, there's kind of 2 different families, and you kind of name them. There's handheld. So let's say you're considering a barcode reader for your application. Yeah. And there's kind of 2 different families. One is a handheld, what I would call handheld. Another is fixed mount. Okay. And there's different terms for them. But basically a handheld is the type that you obviously hold in your hand. You pull a trigger to initiate the read. Okay. So meaning that obviously you have to have someone there to pull the read. These are big in warehouses. Point of sale is a huge one. Obviously everybody knows that one. Grocery stores and that. Yeah. Now grocery stores are in an odd way. You see both. You see the fixed mount reader, which is a reader that is initiated with a signal.
Drag a part by, or, oh man, you bought this huge TV, I gotta walk around and lean over and find the, okay.
Yeah, exactly. Like IKEA is big, all point of sale. So yeah, exactly. So handheld readers can fixed mount readers have a specific range, meaning that they do best at X inches away.
Okay.
They have to be initiated by a trigger, meaning that, or they can actually be put in constant read mode.
Okay.
But like in a grocery store, you'll notice it's not, some of them are on all the time, but a lot of times she'll put it in front, there'll be a sensor that it'll detect, hey, I have a box here, initiate the reader to read it, and that's why a lot of times they're moving it back and forth, it doesn't read, then it beeps, it gets a read, the data goes in. A handheld reader, you've seen those too, they pick it up, they pull the trigger, that initiates the scan, and it reads it. For your application, it depends on what you want to do. Do you want someone to be there to scan the code, or is the product regular enough? I think that's the question I usually go for is it a regular, repeatable object? So, meaning, is it a box? Is the barcode always going to be on this side of the box? Is it going to be at a certain elevation? If so, and is it going to be moving past? That's a big one too. Like, is it going to be on a conveyor, or is it going to be on a moving situation? So where you can say, a fixed mount reader can just sit there, be triggered by a sensor, and then read a code. If not, if the part is irregular or the code moves or something like that, then it's almost a situation where, we have to have someone there who's looking for the code, scanning it. Or you can go to optical readers, which is kind of the new generation, where as long as the code is anywhere on this side of the item, this thing is going to take a picture, identify where the code is, and then decode it.
Oh, that's really cool. So you've got basically like a camera that can locate a code and read it at the same time, as opposed to having to position the code reader. That's really cool. So I know, on that topic, I know that people have used vision systems before, which it can be way more complicated. But so, to me, why would you want to use a vision system if you could just use a barcode reader, which seems more like almost a sensor, like an on-off type of thing?
Yeah, I mean, that's it's a question that a lot of people actually ask, and the main reason is complexity and also price. A barcode reader is going to be your, kind of a handheld reader is kind of the base floor. That's going to be your probably easiest, lowest cost unit. However, you have to have somebody there to pull the trigger. A fixed mount's probably the next price point, a little bit more expensive than a handheld, except that you don't have to have somebody there. An optical reader goes up from there, meaning, now I know that the code is somewhere on the side here, but I want to just snap a picture and then go from there. The next step up would be a vision system. Now, the benefit of a vision system is that much better picture quality. You can get, proper lensing, proper lighting, and get an amazing picture. So if you have kind of a code that's hard to read, or maybe code that's really far away and you need a zoom lens or something like that. The other huge benefit is that now vision systems can do more than just read the code. So you can say, hey, I want to look at the side of this box. I want to check that it's maybe the right label. Yes, I want to check it's the right code, but also, is the bottle on the cap correctly? Is it filled to the right level? So you can read the code, but at the same time, you're analyzing the picture, analyzing the product, and then giving go, no-go signals with the vision system.
So it's kind of two things. Either you've got some crazy code that's very small or really far away, and you can set up your own lensing, whereas with a normal barcode reader you couldn't.
Somewhat limited, yeah.
Or you've got extra capability there in terms of doing the typical vision thing, which is inspection or color checking, things like that, on top of reading a barcode. So, makes sense. Cool. Well, that's all the time we have this week. Thanks for joining us, Caleb.
Thank you.
And thanks to everybody for tuning in. Keep checking in the next following weeks. We've got some podcasts about motion control technologies coming up, and we hope to hear from you soon. If you have any additional questions, feel free to email us at tech@brfa.com.